In this video, we will maximize the mixing entropy using the perturbation method. The mixing entropy of m different types of molecules is -n times kb times the sum of pi times the logarithm of pi. And pi is the probability of a molecule in the mixture being one of the m different types. P sub I is equal to the mole fraction of type I. Now we'll maximize the mixing entropy. Under the same constraint, the sum of all probabilities should be 1. But this time we'll use the perturbation method. So what's the perturbation method? Let's say the mixing entropy is already maximized. And then we will change the probability of finding type 1 to P1 plus delta. The probability of finding a type 2 molecule to P2 minus delta. Delta is infinitesimal. And now we have a change of the mixing entropy. This is the original mixing entropy. And now we replace P1 with P1 plus delta and P2 with P2 minus delta. We have a new mixing entropy. And over here we have the difference between the new mixing entropy and the previous one. If the mixing entropy is at the maximum, well, this expression over delta should be 0 because that's the slope of the maximum. The slope of a maximum or a minimum should always be 0. So all we need to do is we need to look at this expression. On top, that's the new mixing entropy minus the previous one. And then on the bottom, it's just delta, the infinitesimal change to P1 and that to P2. So again, delta is infinitesimal. And we'll just need to evaluate this. If you know the Taylor expansion of the logarithm function, for example, the logarithm of 1 plus delta is approximately equal to delta, and we can simplify this long expression to just 4 terms. It's just ln P1 plus delta over P1 minus ln P2 minus delta over P2. And when mixing entropy is maximized, this expression has to be 0. That means the difference between P1 and P2 must be infinitesimal. And this statement holds true for just any 2 types of molecules. And therefore, all those probabilities should be equal when the mixing entropy is maximized.